Let's start. So today, as part of AWS data engineering, so first we are going to start understanding what is data engineering and what is AWS data engineering and what are the services required to work with AWS data engineering. So these are main important topics we are going to discuss as part of today team. Okay. So first, let's start with what is data engineering. So data engineering purpose is collecting data from different sources, in different format. Your data may be structured, unstructured, semi-structured, and your data may be in CSV, JSON, XML, Parquet, or Avro, or different format. So as a data engineer, we collect this data from different sources in different format. We perform ETL operation, extracting data from different sources and applying transformation based on the requirement and load the data into target. Target may be anything. Target may be S3, target may be Azure storage, target may be GCP, target may be any warehouse. So finally, we load processed transformer data into target source. That data or result may be using by data analyst or data scientist. So whatever data we are going to generate as a output, whatever the data we are going to write into target location, that data going to used by data analyst or data scientist. So data analyst going to generate reports based on our results, or data scientist going to use our results for predictions. So our main target audience are data analyst or data scientist. So we have different types of data engineering team. So main popular one is Apache data engineering. So this one initially most popular data engineering. Initially term was big data. As part of big data, initially we have Apache Hadoop and Apache Hadoop frameworks. Apache Hadoop and Apache Hadoop frameworks team. Later we have Spark and NoSQL databases. So all these concepts included in big data engineering, and later term is changed to data engineering. Initially people called same technologies, people called big data, but later terminology is changed data engineering. So Apache has a lot of products in Apache data engineering, like Apache Hadoop, Hadoop frameworks like Apache Hive, Flume, other services, NoSQL databases like Apache Cassandra, and lot of NoSQL databases, and Spark, Apache Spark. Apache Spark again supports 4 languages: Spark with Java, Spark with Scala, Spark with Python, Spark with R language. So initially, most popular one is Apache. Apache products, complete Apache products are free. You no need to pay a single rupee for downloading, installing, using Apache products. But finally, where we are going to install all these products is on any cloud platform, maybe AWS, maybe Azure, maybe GCP, or any other cloud. So finally, infrastructure, we are going to use cloud vendors. So initially, cloud vendors started supporting this Apache data engineering components, and they added their own storages, their own NoSQL databases, and slowly they invented data engineering components. When you come to AWS data engineering, AWS data engineering has their own storage called AWS S3, NoSQL databases, streaming technologies. Lot of other services they slowly added into their services stack, and finally industry started using cloud vendors data engineering services. So we have AWS data engineering, we have Azure data engineering, we have GCP data engineering. These three vendors having most demand nowadays, team. So if you want to become data engineering, in Apache data engineering, only one component is important, that is Spark. In that Spark, people are mostly using PySpark. PySpark means Spark with Spark with Python team. So I said Spark supports 4 languages: Spark with Java, Spark with Scala, Spark with Python. If we write Spark programming using Python, we call it as PySpark team. And Spark also supports R language. So in all these data engineering services, like when you come to AWS, in AWS, there is one technology called AWS Glue. So AWS Glue can be used for ETL operations too. So in this AWS Glue, again, we choose 2 languages too. One is Scala and other one is Python. So in AWS Glue, we choose a programming language, either Scala or Python, and it also provides GUI environment, graphical user interface for defining ETL jobs. So in initial versions, you have to write everything in script file. Later, they modified lot in AWS Glue, and they are providing graphical user interface. There you can define your ETL job, but this ETL job you can choose programming language. Then it will generate either Spark and Scala code, or it will generate PySpark code. So like AWS, we have Azure Data Engineering and we have GCP Data Engineering. So these 4 are most popular in data engineering world team. So these 4 data engineering services are most popular, but nowadays huge demand for these 3, and very less demand for Apache data engineering services. Still people are using, but very less. So in Apache, most popular one is Spark. Still AWS or GCP or Azure backend, they're using Spark for generating ETL code. Hope all of you understand what is the purpose of data engineering. Now let's start with AWS data engineering team. What is AWS data engineering? So AWS data engineering mainly focus on data collection and data analysis, and it performs ETL operations. And one important point I will cover is all cloud data engineerings. Cloud data engineerings, maybe AWS, maybe Azure, maybe GCP, we use ELT operation. We extract data from different sources. So we extract data from different sources and we load that data into data lake or data store. So first we load data into data lake, and then we apply transformation. That transformed data we are going to store into warehouse. So nowadays we have modern warehouse. Every cloud vendor has their own warehouse. In AWS we use AWS Redshift as a warehouse team. So every cloud vendor, every data engineering cloud vendor uses ELT operation, extract data from different sources, loads data into storage or data lake, and then we apply transformation operation using services like Glue. So every cloud vendor, we use the term ELT operation. So generally we do what? ETL, extracting, transformation and loading. But in cloud data engineering, we use ELT operation. Okay. Process is same, but concept is same, but process implementation is different. We extract data from different sources and we load into storage. Let's take this scenario team. So to ingestion purpose, we have different services. One is AWS Glue, another one is AWS Lambda, another one is AWS Transfer Family, and we have multiple other services like AWS Kinesis. So we have different sources. From these sources, by using any of these technology, we ingest data into storage called AWS S3. In AWS, this is most popular storage service. It stores data in a object format. It supports unlimited storage, and it supports different types of data like structured, semi-structured, unstructured. So it supports all kinds of format and stores data in a objects formats. So we ingest data in this, let's say this one is data lake or storage, or we can say this layer, first we can say raw layer. Raw layer means unprocessed data. So we connected different sources, we ingested data as it is without any changes using these technologies. Once data is presented, we apply transformations. We apply transformations using AWS Glue, using Spark plus Python. So here we use two approaches. So in any data engineering, we use two teams, data engineering. Let's say data engineering. It may be AWS, it may be Apache, it may be Azure, it may be GCP. Data engineering implementation we do in two ways. First preference is SQL. So most of the people think data engineering is programmatic. So most of the people think data engineering difficult because they do not have idea. So most of the time, data engineering implementation, we implement using SQL approach to first one, and other one programming. In this programming, most of the time people uses Python tip. You can implement using Java, you can implement using Scala, you can implement using R language. Most of the time industry uses Python. So first let's understand SQL team. So learning SQL is very easy and implementing SQL is very easy, and SQL approach is less code and takes less time for implementation. So you are maybe programming background, you may be non-programming background, coming from testing, coming from non-other programmings like reporting background, warehouse background, DBA background. So this one is very easy. So first approach thing, data engineering implementation using SQL. But one important point we have to remember is SQL is not solution for all the problems. SQL is not solution for all the problems, but programming language can provide solution for any problem in universe. We can provide solution using programming language. That is the power of programming languages. Maybe C language, maybe Java language, maybe C# language, maybe Python language. Programming languages provide solution for any universe problem. That is the power of programming languages. So in data engineering, first we go with SQL implementation. SQL implementation. Let's say you have a problem. You have a problem. Problem 1. You have a problem 1. This problem using data engineering, let's say you are using PySpark with Glue. So you are writing transformation logic. In that AWS Glue, you are choosing SQL approach. So this problem you are trying to achieve maximum of 90%. 90%. But 10% you are unable to provide. Assume 10% solution you are unable to provide. Then with this programmatic approach, we have a RDD concept. So we have two different concepts. Let's say SQL supported is Spark SQL. Let's say PySpark SQL. PySpark SQL. With a PySpark SQL, you are achieving 90% solution, but 10% you are unable to achieve. Then we have a concept called PySpark core programming. In that we have a concept called RDD. With this 10%, you can achieve using RDD and you can generate some part of result. That result you can convert into SQL format called data frame. Then you can continue with SQL approach too. So understand right, team? So whatever the part you are unable to achieve, that you can write a programmatic approach. Then you can continue generating data frame. Then you can continue SQL approach. 90% of solutions in data engineering, we follow SQL approach team. That's what. Who has SQL knowledge? Who has good SQL knowledge? They can easily survive in data engineering world. Don't think programming plays important role. Programming also important, but most of the time we go in SQL approach. Wherever SQL is not supporting, we go programmatic approach. Programming is the solution for any problem too. I said it may be any programming language. I am not saying Python is the only one programming providing all the solutions. Every programming language has capability, but maybe some may be very huge code, some may be smart code. So Python is one of the programming which supporting three kinds of techniques like scripting oriented, functional oriented, object oriented from the beginning, 1991. Initially, people not recognized importance of Python. Later, after big data was invented in 2014-15, industry used legacy programming languages. They come to know very lengthy programs. They come to know importance of Python. They started using Python. Then Python become very popular due to programming supporting three features. We can write individual scripts. In that script, you can write only functions. In that script, you can write pure object-oriented programming. In that script, you can combine three approaches. That is the main advantage, beauty of Python programming. Nowadays, multiple languages trying to achieve similar to Python, but they are losing their actual importance. So still Python is the powerful language in data engineering side, data analytics side, and data science side. So industry is still using Python as programming language in data engineering implementation, data analytics implementation, and data science implementation team. Yeah. So, first we ingest data from different sources. We store into storage. This one we call it as raw layer. From raw layer, we are going to apply transformation. Transformed result we store temporarily into storage. Storage may be AWS S3, other storage. This one we call it as staging area. So before persisting results, transformed results directly into final target sources, before persisting into final target sources, we persist transformer result temporarily into stage area. Once we validate all the results generated properly, then from this stage area we move to target source. So in this way, AWS engineering applications happening. So here I mentioned a few services. We are going to discuss what are different services available in AWS data engineering and what is the importance of each service. Okay. So we have different services. So first one, AWS EC2. So AWS EC2 is a service which can be used for infrastructure as a service too. We can create virtual machines and we can choose a required operating system. We can choose required resource sizes. I want one virtual machine with 64 GB RAM and 16 core processor with Ubuntu operating system. So by using this service, we can create infrastructure as a service. And next one, IAM service. IAM service most of the time AWS admin uses, but we have to know IAM service little bit. We are not going to create a users and we are not going to assign policies and roles to users, but we must have a knowledge on AWS IAM because we have different AWS services. Let's say Glue and let's say AWS S3. So we are writing Glue application. Let's say we are writing Glue application. So our requirement is we want to connect S3. We want to connect S3 and we want to do some transformation and result again we want to store into S3. Here we need some permission. We need a permission. This application must require some permission. You have to know that permissions, what are different permissions are available or policies are available. How you can request admin, maybe AWS admin, maybe AWS DevOps admin. We request admin to allocate services, allocate permissions. So at least we should have minimum knowledge of IAM service team. IAM stands for Identity Access Management. So we do not need in-depth knowledge of IAM, but at least minimum knowledge of IAM knowledge team. And next, we need very in-depth knowledge about storage. So usually we are going to interact with the storage multiple times during AWS data engineering application. I said our input source may be this one. Okay. This input source may be this one. Target also this one. Sometimes target source also this one. And we also use this one for raw layer. We are using many times this one as a raw layer, and we also using this one for staging layer, and we also using this one if it is target means this one we are using for persistent layer. Correct. So to persist our result, we are using this one for persist layer also. So storage S3, we are going to interact many times in our data engineering life cycle. So you should have in-depth knowledge. Minimum knowledge is more than enough. If you have a very in-depth knowledge, then you can do multiple things while performing or while writing AWS data engineering application team. Next one, RDS team. RDS is the service. It provides relational database as a service. As part of this one, they are giving MySQL, okay, and they are giving Oracle, Oracle. They are giving PostgreSQL, PostgreSQL. They are giving Microsoft SQL Server as a service. Without this RDS, we can create our own virtual machine by using AWS EC2. Without this RDS, we can create EC2 instance. We can install required database. We can install required database. But compared to RDS with our own approach, lot of advantages with RDS team. Here, we are going to install, we are going to monitor, we are going to troubleshoot, we are going to perform patching, updates, latest updates, we are going to take backups, we are going to do lot of manual activities. Those manual activities completely we give to AWS. Some manual activities we do, but 80 to 90% going to taken care by AWS people. We least bother about those things. We mainly focus on our development. That is the main beauty of AWS RDS. Okay. Along with this one, they also give their own database called AWS Aurora or Amazon Aurora. Okay. So we have different services team. So this is maybe our source. This may be our source, or this may be our target. Depends upon our client requirement. So this may be our source, this may be our target. So you need to have minimum knowledge of RDS team. And next one is DynamoDB. DynamoDB is NoSQL database team. Nowadays, most popular is NoSQL database. And along with this NoSQL database, and they are giving MongoDB as a document DB as a service tip. AWS managed MongoDB. So this is also either DynamoDB or AWS managed Mongo document DB become our NoSQL databases. So these are maybe sources, these are maybe targets for our data engineering. And next one, AWS Lambda team. AWS Lambda also we use for data ingestion, but it supports very less and it has a lot of advantages compared to other services. Here we can write triggers, and we can also call jobs also. So let's say I have a ETL script, let's say I have a glue job. Before glue job, I want to check whether files are generated in my source. Let's say AWS S3. AWS S3, what we are doing, we are getting daily files. Let's say our script, whatever the script we return, ETL script, whatever the script we return using glue, So let's say this glue is executing every day at 8 a.m. 8 a.m. Every day 8 a.m. Every day 8 a.m. it is executing. So it is expecting some data in AWS S3. In that we are getting file 1, and file 2, and so on. We are getting file n. Assume file n. In that there is one file called file 2. This file is very important to perform ETL operations. This file 2 is very important. Assume this file 2 is very important. Even multiple files are generated. This file is very important. Before running this glue job, I want to verify this file is created or not. So here I can write a trigger using Lambda. This is one purpose team. This is one purpose of Lambda. Lot of purposes for Lambda. This is one purpose. In my case, I'm writing one event trigger. So before my glue job, I want to verify file 2 is generated or not. Sometimes in file 2, some data we are going to validate. Such kind of triggers we can write in AWS Lambda team. AWS Lambda also very important, and AWS Lambda supporting multiple languages. In that, one most popular language is Python team. So you can write Python coding in AWS Lambda. And other important services, Glue. This is our main hero in our AWS team. In AWS data engineering is AWS Glue. One thing, so we have a most powerful tool called PySpark. So this PySpark mainly we use for ETL operations. So instead of writing lot of code using this PySpark, they given AWS Glue. If you use PySpark, pure PySpark, we have to set up our own cluster. We have to provision multiple EC2 instances. We have to set up a cluster, and we have to install Spark software in cluster. Then we have to write a script. Then we have to deploy the script into this cluster. So this is actual approach in PySpark. Coming to AWS Glue, this one is a serverless architecture. What is the beauty of serverless architecture is you can specify, let's say, I want minimum resources are 1, max resources are 256. I'm specifying min I want 1 mission, max I want 256 missions. And I have data in S3. I have a data in S3. I have a smaller data. I send processing request to AWS. I configured minimum 1, maximum 256. Then AWS Glue, based on your input size, it creates 1 mission and process your request. Assume your data is huge, and depends upon that data, it will create 1 or 2 or 3. How many missions required, it will create those many missions and runs your request. Once your request is completed, it will remove these missions. So AWS people charging only how much time taken, how many resources allocated for that task. Let's say 1 second, 1 second taken and 3 missions involved. In 3 missions, 8 cores, 8 cores and 16 RAMs, 16 GB RAM, sorry, not 16 RAMs, 16 GB RAM. So 3 into 8 cores, 3 into 16 GB per 1 second, they will charge. That is the beauty of serverless architecture team. Dynamically, they will create resources, they will process, dynamically, they will release resources too. And next important one in AWS data engineering is AWS EMR team. I said we have a PySpark. I said we have pure PySpark. I want to fixed cluster team. I do not want dynamic cluster. I want a fixed cluster. I want 600 missions. In my cluster, I want 600 missions or 300 missions. I want a fixed cluster. Then by using AWS EMR, instead of manually setup, instead of creating EC2 instances, installing required operating system, installing required data engineering services or big data services, we can choose a AWS EMR and we can choose pure Hadoop or we can choose Spark and we can choose required services. It will install all the services and with a fixed cluster. Then you can develop a Spark application. You can submit that Spark application to this cluster. In that scenario, people go with AWS EMR. I always say this architecture industry stopped it. Very few cases still people are using, but this architecture is stopped. Instead, industry going like PySpark, PySpark. Instead of EMR, people are going PySpark with Kubernetes architecture team. So they are going to set up Kubernetes cluster, Kubernetes cluster. Okay. In the Kubernetes cluster, they have a containers. These containers dynamically creates and Kubernetes maintains this cluster. And we are going to deploy our PySpark applications on Kubernetes cluster. Like serverless only, but Kubernetes with PySpark also has a huge demand in the marketing. And next one, Kinesis team. Very important service is Kinesis. And along with AWS Kinesis, there is one more important service called Kafka, Kafka managed service. Kafka as a managed service. So AWS has Kafka managed service or AWS Kinesis. AWS Kinesis is their own. Kafka is from Apache. They are supporting streaming purpose these two architecture type. You no need separate EC2 instance creation. You no need install Apache Kafka services in EC2 manually. They are providing AWS managed Kafka as a service. Okay, you can use streaming purpose AWS Kinesis or Apache Kafka managed service in AWS. These two are streaming purpose team. You may know streaming means assume this is my log file. Just I'm giving clarity. So I have a traffic signal, traffic cams in different locations. So when any picture comes, they are writing continuously. If any location data is continuously generating, this one we call it as streaming. So to read this streaming data, in industry, we have multiple technologies. One is Apache Kinesis, another one is AWS Kinesis, another one is Apache Kafka, and lot of services team. These are most popular. In AWS, along with streaming, it has other services also team. So if you want a pure streaming service with text data, we go either Kinesis Firehose or we go with Apache managed service in AWS as a stream. If you want video and other things, we go with AWS Kinesis system. It also has additional features. Most of the time, industry go with this streaming data services team. So in that case, you go either AWS Kinesis or Amazon managed Kafka service team. You can go with Amazon managed Kafka service. And next, very important one is Amazon Redshift or AWS Redshift. So this one is a data warehousing technology. Redshift is a modern data warehousing technology. It supports huge volumes of data. Huge volumes of data. Once we apply ETL operations using Glue, most of the time, our target source is Redshift. Redshift has supporting of unlimited storages. Along with this one, it also supports ML, machine learning, or multiple uh, data science supporting. So Redshift is cost compared to other warehouses, but it has a capability of storing unlimited storages, and it is a service of AWS who are working with AWS data engineering. Maximum they choose warehouse as AWS Redshift tool. Maximum. I'm not saying 100%. Maximum clients they choose Redshift as their warehouse service. From this, data analyst may be going to connect, generate reports. Data scientist may going to connect, generate predictions. So for our ETL, this is one target source. One target source, most of the time, as an AWS data engineer, most of the time, we are going to work with Redshift. Finally, we are going to persist our results into AWS Redshift. So here, minimum knowledge is more than enough as a data engineer team. As a data engineer, minimum knowledge is more than enough. If you have a in-depth knowledge of Redshift, you will get more preference. You will get more preference. And next important service is AWS Athena team. AWS Athena. What is AWS Athena. I have file in S3 team. I have a file in S3. I want to work with this S3 file. I want to work with this SQL file using SQL commands. Then Athena provides, AWS Athena provides this approach to me. You just write simple SQL queries. You just write simple SQL queries to interact with S3 system. Okay. So Athena provides SQL interface to interact with files which are presented in S3. And along with this one, you can create views, you can provide views, lot of additional features. But the main purpose of Athena is to interact with SQL using, to interact with S3 using SQL. Okay. Next important service is AWS Quick Cited. You may heard Power BI, Tableau, and other reporting services, right? Similar way, AWS also has their own tool called QuickSight team. By using AWS QuickSight, you can generate reports. And next one, step functions team. Step functions. You may have multiple scripts, script 1, script 2, script 3, script 3. I want to execute first the script and I want to execute second the script. So this script is depends upon the script. And if this script successfully execute, I want to call this script. If the script is failed, I want to call this script. So like this, if you want to define pipeline, then we go with step functions. One thing, AWS Glue has internal defining pipeline and scheduling pipeline, but that is only for AWS Glue scripts. But AWS step functions can be used for any of AWS services, any of AWS services. And along with AWS step functions, people also go for Airflow. Airflow. Airflow is from Apache team. This is from Apache. Apache. Glue only for Glue jobs. Glue scheduling, defining jobs is only for Glue job. Step functions are for any of AWS service. Airflow for any universal service. Maybe AWS service, maybe Azure service, maybe GCP service, maybe anything, universe. So one more important point thing, AWS also providing AWS managed Airflow service too. Instead of taking AWS EC2 instance, installing Airflow, AWS also providing AWS managed Airflow as a service. You can go with AWS managed Airflow as a service. And along with this one, I have some other additional supported services called SNS. If anything failed, if any receives filled with data or lot of tasks, then we want to notify. Then we use SNS, SQS, and other services called Event Bridge, CloudWatch, Secrets Manager. These are additional supported services for AWS data engineering team. Okay, so by using these AWS services, we perform these kind of operations team. Data sources. Data source may be S3, RDS, DynamoDB, Kinesis, And data formats may be text format, CSV format, JSON, XML, Parquet, Avro. We use data ingestion. Batch purpose, we use Lambda, Glue, EMR. Streaming purpose, we use AWS Kinesis, AWS Kinesis Data Analytics, and Firehose, AWS managed Apache Kafka, and data lake temporary raw storage purpose, staging area purpose, we use S3, and data catalog, very, very important. Here, data catalog is a part of AWS Glue team. So what is the beauty of AWS data catalog is initially they developed for Glue. So it holds meta information. Let's say I have a file in S3 which contain multiple columns, and each column has a different data type. To persist that information, they developed data catalog concept in Glue. So they persisted that information in Glue. Initially, that was developed for Glue, but because of this purpose, this may be useful for multiple services in AWS. So uh, uh, later on, it is become central repo for all the AWS services team, like Athena. Athena, we are writing SQL query, we need meta information. So that meta information iterate from this AWS Glue catalog. Okay. Coming to next one, AWS Redshift. Just now we discussed target, we use what? AWS Datashift. And data analytics purpose, we use QuickSight, Athena in SQL way. And application integrations. Let's say I want to send notifications. Then SNS, SQS, Event Bridge. Data pipeline orchestration. Glue has its own internal, but it is only for Glue, and AWS step functions for all the services which are presented in AWS, Apache Airflow for anything in universe, and monitoring tool AWS CloudWatch. So these are different AWS data engineering prerequisites. So if you want to become AWS data engineering side, first you need to have minimum fundamentals knowledge, creating account, creating EC2 instances, what are free tiers, what are services comes under free tiers, such kind of fundamental knowledge. And Python for AWS data engineering, SQL for data engineering, Linux for data engineering, PySpark for data engineering. And along with this one, Git or GitHub for AWS data engineering. So once we write, we persist in any version control systems, minimum knowledge. Minimum knowledge is required for AWS data engineer. These are prerequisites. These are main services we use in AWS. These are other services, supported services for AWS data engineering. Hope all of you understand AWS data engineering team. You have a option of unmute. If you have any queries, you can unmute and you can ask me team. Or you can write in chat box, or you can raise in hand symbol so that I will give unmute option if you do not have unmute option.
Yeah, so I have a question. So
Yeah,
all the prerequisites which you said, like in the
yes, yes.
database data engineering, so they will be covered in the course.
Yes, we are covering these prerequisites, we are covering.
Means you will be teaching right from basics to like programming in PySpark database. Right?
Yes, yes. What are the roles of AWS data engineer? ETL, extracting data from different sources, loading into storage layers, and then applying transformation. Transformed results we are going to persist into warehouse. 90% of work is ETL operations. Any data engineer friend.
Will be covering anything related to Snowflake or Databricks?
No, Snowflake. So warehouse, we are here choosing AWS Redshift team. So main important point why I chosen this AWS Redshift is maximum projects, AWS data engineering projects, maximum. Who chooses AWS services for their AWS data engineering application? Maximum warehouses AWS Redshift. Who want Snowflake? Then we have a separate AWS data engineering integration. They can opt. So I always recommend AWS Redshift. If you want Snowflake instead of Redshift, then you can opt. Instead of Redshift, you can opt Snowflake. That is also good stack.
So which one you prefer in current market conditions?
I always prefer Redshift.
Okay.
Any other questions, team? Hope all of you clear. If you have any queries, you have an option to unmute. You can ask me, team. For any query, you can contact management so that they will give clear information. So you can contact them. You will get syllabus also. Okay. Yeah. Okay, team. That's it for this session, team. If you have any queries, you can ask me. Otherwise, we'll connect later. For any information, you contact admin team.
Sir, if we opt for this course, the same time you will continue the course for next 2
Yes,
months.
yes, yes.
So it will come. You will take 60 days, 60 working days to complete this course, right?
Yes, correct. It required 60 working days. Time.
Yeah. So Friday, Monday to Friday.
Monday to Friday.
Okay.
Optionally, we take Saturday, Sundays, but Monday to Friday is main.
Yeah. Okay.
If we choose Snowflake, how we can app here?
I
Are
said
you going to explain?
you can instead AWS Redshift, you can choose Snowflake. We'll take parallel.
Yeah.
Any other questions, team? So let's say some people want AWS Redshift. So AWS data engineering with Redshift team. They can choose. You can choose Redshift. Or some people want to Snowflake. Snowflake. They can choose Snowflake with AWS DE with the Snowflake. So we are going to take one end-to-end project team. End-to-end project. This end-to-end project, we implement either AWS data engineering with Redshift or AWS data engineering with Snowflake. So who chooses? We implement the same thing using Redshift, this approach, this stack. Who chooses Snowflake? we change same implementation using Snowflake team. Let's say 10 people chosen this one, 10 people chosen this one, but until this warehouse concept, all are combined in same course. But while talking with discussing with the Redshift, these 10 people shifted to other time. Let's say this one is 8 to 10, 8 to 9. This one is 7 to 8. Or some other possible timing. So this end-to-end project, whatever we are going to cover, that we are going to change stack. Other than that, everything is same. Only warehouse part is different.
Okay. So when it comes to Redshift, you will cover both separately for who opts separate. Yeah.
Yes, yes.
So till then it is same time and same batch.
Same batch.
For other only Redshift and Snowflake is different. Okay.
Yep. Okay. Any other questions too? No? Okay. You can contact Sriman admin team. They will give clear info. Okay.
Yeah.
Yeah. Thank you.
Okay. Thank you.
Yeah. Thank you.
Yeah, okay. Thank you.